stop, 1. Okay? So anytime, this is the key thing, when you get the 0 there, stop. So now that's the MSB. Remember, it goes from LSB to MSB. So we got to rewrite it, just kind of drag and drop it this way. So it's 1, 1, 0. So 1, 1, 0, 1, 1, 1. That's our answer. 1, 1, 0, 1, 1, 1. So you should be able to check your work. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. So that's 32, 16. Don't worry about 2 to the 3, which is 8, plus 4, plus 2, plus 1. Oh my gosh, it's 55. Okay? So, do 39. Show me what you got there. So go ahead and pause the tape on the count of 3. 1, 2, 3, pause. Okay, we're back. So we're going to try 39 using the repeated division by 2 method. So what do? Divide it by 2. 39 divided by 2 is equal to 19. The remainder 1. Again, it's odd, so one would expect our LSB to be 1. So 19 divided by 2 is equal to 9, remainder 1. 9, keep on working it down. See how it's kind of, well, an algorithm. It's doing the same thing over and over. And this is what machines excel at, is they don't get bored. So 4, remainder 1. Yeah, because 2 goes into 9 4 times, but then there's 1 remainder. 1. Take out 4. 4 goes into 2. How many times? 2, remainder 0. 0. Take out 2. How many times does 2 go into 2? Goes in 1 time. Remainder 0. 0. How many times does 2 go into 1? It goes in 0 times. Remainder 1. Stop. Anytime you get that guy, stop. And then that's our MSB. Again, kind of drag and drop everything. Sorry, it's on a couple pages here. So it's 1, 0, 0, 1, 1, 1. Check your work. Are you okay? I'll rewrite it. Is that no? Goes to that. Okay, so check our work. So this is 2 to the 5, 2 to the 4, 2 to the 3, 2 to 2, 2 to the 1, 2 to the 0. So 2 to the 5 is 32. Don't need to worry about those two guys. 2 to the 2's 4, 2 to the 1 is 2, 2 to the 0 is 1, 39, nice job. Okay, what about fractions? Still kind of the same concept, is basically the sum of weights, and instead of repeated division by 2, this is repeated multiplication by 2. So 2 different methods. Fractions, there's sum of weights, and then there's the repeated multiplication by 2. First off, let's go into sum of weights before we get into anything else. Basically, this is also equivalent to a table or a memorization method. If you remember right, anything to the right of the decimal place is decreasing powers of 2. So 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, 2 to the negative 4, that's a 4, 2 to the negative 5, so on and so forth. And if you think about that, what that means is 1 divided by 2 to the 1, 1 to the 2, 3, 2 to the 4, 2 to the 5, so on and so forth. And if you go ahead and do all the multiplication here, excuse me, all the exponents, 1 over 2, 4, over 8, over 16, 1 over, Jesus, sorry, 82. So you get it? It's decreasing in magnitude. So do this in decimal places, it's 0.5, 0.25, 0.125, 0.6, what is that, 0.65, 625, geez, 625, 0.03125. Okay, see how they're basically decreasing in magnitude in that direction. Some weights, you got to memorize this table. It's, you know, you don't even really need to remember it. All you need to do know is this. All you need to know is that, actually. Because this up here, give you all that. Okay, so let's just use an example. Example is 0.3125. How many of these numbers here add up to 0.3125? Well, 0.5 not going to work, but 0.25 certainly works. So 0.3125 minus 0.25. So, well, first of all, it's not 0.5, 0.5. So there's 0. 0.3125. There's definitely a 0.25 in there. So there's a 1 there. So we did this 0.3125 minus 0.25, leaving us 0.0625. Well, there it is right there. So 1. Just so happens to be. So how we can reassemble this? I'll just do this right. Oh, I figured it out. I skipped this guy here. Of course, there's no 0.125. Sorry about that. Let's do this over. So 0.3125. 0.5. There's no 0.5s. 0.25. There's one of those in there. Keep on going to the next one. 0.125. Nope, there's none of those in there because there's a remainder of 0.0625. 1. Okay? Just reassemble this thing. It's 0.01. Sorry about that, guys. I got so excited when I saw that there and just jumped to it. Okay? So, let's do repeated multiplication by 2. Again, this is not making